So yesterday we were looking at these derivatives of trig functions, and we had some basic limits that were given by geometry. The limit at sine theta was 0, cosine theta was 1, sine theta over theta, that limit was 1, and cosine theta minus 1 over theta was 0. So any limit that you're given, you want to try and write it in terms of these four basic limits. So for example, with the sine 3x over 5x, we pulled the 5 out in front, so we had 1/5. And that left us sine 3x over just the x, and then we multiplied and divided by 3 so that the 3x right here agreed with the 3x right here. So then it looks like sine theta over theta, except instead of theta, 3x. And then in example 2, we had sine cubed theta over 2 theta tan theta. We changed the tangent to sine over cosine, inverted and multiplied, and that let us cancel one of the factors of sine, and that gave us sine squared theta cosine theta over 2 theta. We took the 2, brought it out in front, 1/2, because that's in the denominator, and then we broke our numerator up into sine theta, and cosine theta, so that's our sine squared cosine, and we took the theta and put it underneath the sine theta. So these guys really have a denominator of 1. And then sine theta over theta, sine theta by itself, and cosine theta by itself, we know those here, here, and here. So again, we wrote it in terms of limits that we know. And then the limit of this product was the product of the different limits. Sine theta over theta went to 1, sine theta went to 0, and cosine theta went to 1. So that gave us 0 for an answer. So let's take a look at another example. We haven't used this yet. Cosine theta minus 1 over theta, that limit's equal to 1. So we want to try and use that limit there. So here we've got 1 minus cosine h, quantity squared over h sine h, limit as h goes to 0. So let's see here. I am going to break this product up here into two pieces. This will be limit h goes to 0. And then I've got 1 minus cosine h. And then another 1 minus cosine h. So I've got two factors of those. And I'm going to leave this h in the denominator on one, and then the sine h in the denominator on the other. And again, if we were to multiply straight across, we would get this back again. So now limit of the product is the product of the two separate limits. So I've got limit 1 minus cosine h over h as h goes to 0 times the limit h goes to 0, and then 1 minus cosine h over sine h. So 1 minus cosine h over h, that almost looks like this. If we replace the theta with an h, we'd have cosine h minus 1 over h. Well, this is just the negative of that. So if we wanted to, we could put a negative out in front and then change this to -1 positive cosine. So now it's cosine h minus 1. So this piece here is going to approach 0. And then as long as this limit doesn't go to infinity, we'll be okay. So let's see what happens here. As h goes to 0, cosine of h approaches 1. So this looks like 1 minus 1. And then sine of 0 in the denominator. So it's 0 over 0. So this part's 0 over 0. So we need to make sure that that 0 over 0 does not go off to infinity. So let's bring this limit down here and work on it separately. So limit h goes to 0. We've got 1 minus cosine h over sine h. And again, it is form 0 over 0. So I want to, let's see here, I'm going to use some trig editing. So I'm going to multiply by 1 plus cosine h top and bottom. And you'll see why here in just a second. So it's kind of like multiplying by the conjugate when you've got square roots in there. So now all we did was multiply by 1. And if you multiply straight across here, limit h goes to 0. First terms here, 1. Outer terms, cosine h. Inner terms, negative cosine h. Those cancel. Last terms, minus cosine squared h. And then on the denominator, just multiply straight across. Sine h times 1 plus cosine h. Now it still looks like 1 minus 1 over 0 times 1 plus 1, still 0 over 0. However, 1 minus cosine squared is the same as sine squared, right? Because sine squared of h plus cosine squared of h is equal to 1. So if you pull this guy over as a negative, 1 minus cosine squared equals sine squared. So this is actually the limit. H goes to 0. And we've got sine squared h in the numerator. And in the denominator, sine h, 1 plus cosine h. So then this sine h will cancel off one of those. And this is now limit. H goes to 0. We've got sine h on top. And 1 plus cosine h in the denominator. This is no longer 0 over 0. The top is going to 0. Bottom cosine of 0 is 1. So this looks like 1 plus 1. So this is 0 over 2, which is 0. So that limit is 0. So this piece is going to 0, but then this limit is also 0. So this is actually 0 times 0, which is 0. So that one's a little bit of work because you had to break it apart into two pieces. And then to find the limit of the second piece, we had to multiply by conjugate here, top and bottom.